Okay, I have 3 mass over here. I have 3 mass over here linked by very small mass, and I'm throwing this to you. Okay, what you see is the motion of the center of mass. What you see is, even if it is rotating, you can see some point, right? Okay, the next lecture you will find that that is the center of mass. Okay. If it just up and down, if it just up and down, no rotation, that is simply M1 times A1, M2 times A2, M3 times A2, A3, but A1, A2, A3 is the same. That's the case. That's the case, this case, because all 3 masses' acceleration is the same. That's not interesting. That is so obvious. But if it does have some velocity with respect to center of mass, that is the interesting part. And your clever guy already anticipate or guess, oh, next lecture you will explain if you have a system of particle, then what we can see is the motion of a center of mass, okay, M1, M2, M3 collapsed in one point, and there is F1, F2, F3. We know how to analyze that problem, right? We already knew from particle dynamics. And the rest is simply what has to do with the rotation of small mass. Small mass, right? So the motion of this is motion of this plus motion of this one. And what is the motion of this one? That is the motion with the rotational motion with respect to G, center of mass. Okay, that's very interesting part. So how do we do it? Let's see. Moment of this vector. Okay? So let's look at the moment of this vector. I invite this coordinate, and then this is R1 vector, and this is R2 vector. And I also, again, invite the same coordinate, and this is R1 vector, and this is R2 vector. Reason why I invited the position vector R1 and R2 is because we want to look at the rotation, and the rotation certainly related with the moment. Okay, this part is the essential element of rigid body dynamics, which is quite different with what you've learned in dynamics of particle. And the concept which will be introduced with many, many errors, because I do not know very precisely, and I want you to find out those errors. is an essential part of this course. Okay, then what I can say is R1 vector cross product F1 vector plus R2 vector cross product F2 vector has to be equal to R1 cross product M1 A1 vector plus R2 cross product M2 A2 vector. Is it correct? Yes, it should be correct because this pictorial expression of Newton's second law is a correct one. The things, what I just added is the position vector, and I take a moment with respect to all the vectors. That's mathematically correct, completely correct. But you can say, no, you didn't consider all the external force. Do I have to consider all the external force, internal force? And somebody asks, because Newton's second law has to be applied to each mass, so you have to consider all the internal force, because this equation valid only for each individual mass. That is true. Therefore, I use F12 here, F21 vector, and the vector, therefore, there should be R1 cross product F12, there should be R2 cross product F21. Okay? And what is this? You know that M1 A1, M2 A2 is equal to M1 plus M2 and AG vector, but we do not know how this one is related to each other. Okay? Then how we investigate the property of this moment expression? This is the acceleration expression. Therefore, we move to, as we did before, momentum expression and displacement expression as I did before. And we will come up with a very interesting result. Moment acting on center of mass has to be balanced by angular momentum vector change with respect to time. That's the governing equation for rigid body. Very simple form, but very difficult to implement. So next lecture, I will show how this is related with that, and how we use this rather simple form of rigid body dynamics or system of particle in practice.